All right, good morning, everyone. Okay, that was remarkably subdued, like three guys in the front said good morning, so good morning, everyone. Good morning. Hey, that sounds a lot better. I guess not everyone is still hungover from last night. No? Okay. So I hope you guys are all excited to see the new features we've got in F12, the F12 developer tools that we're updating with this patch to IE 11. I am very excited to be up here to be able to demo these tools. We've had a great team. They work in Redmond, they're working in the St. Paul area in Minnesota, build these tools, and it's a real privilege for me to be up here and show these new features to you guys. You know, that these tools, we've continued to improve on this release. So hopefully you'll really enjoy the demos we have today and see a whole bunch of new cool stuff. So firstly, by way of introduction, I'm Andy. Yeah, hey, I wave, we still use IRC. So I work as a program manager on that aforementioned kick-ass team, and we build the tools that are in Internet Explorer, the F12 developer tools, as well as the developer tools for Windows applications that use JavaScript, like Windows Store applications, be it on the phone or big Windows. So are any of you guys in the room developers that build those sort of applications? So you're mostly IE developers, I guess, mostly targeting, mostly web developers, yeah? That's great, because you're in the right room. But to be honest, so I build both. I work on the team that builds both those tools, but my personal favorite definitely has to be F12. I love the tools because they're singly focused. You know, Visual Studio is great, it has such rich set of capabilities. It does more things than I think any one person really could ever understand. But F12 is fantastic because we focus on trying to help you as a web developer build beautiful sites that look really good, that function well, and are fast, and to use the phrase, fast and fluid. So it's really great that we get to work on such a focused area and build some tools, which I'm going to show today. So the features I'm going to show today are all part of the Windows update that's going out, I believe, next Tuesday, which is the 8th. And so they'll be applied to both Windows 8.1 customers and Windows 7. So there won't be a difference, or there shouldn't be a difference, between what you have with IE 11 on Windows 7 and what you have with IE 11 on Windows 8.1. You'll get the same platform, the same tool experience. The other exciting thing, of course, is this is a relatively short time for us since we last shipped. We just shipped IE 11 in November and October, and I know our updates can sometimes feel a bit glacial in pace. But this update is going to add a bunch of features. You've already hopefully heard about enterprise mode, perhaps. You've heard about some of the WebGL improvements, and we've also added a bunch of tool improvements, which I'm going to show today. So it's a pretty awesome thing for us to be able to do, is to update the browser and not, wait for a long period of time. So you guys as developers can see features more quickly. You got a question already?
Yeah, when do you expect the Windows 7 to be used for the enterprise?
I couldn't speak to enterprise mode questions, but we can follow up afterward for enterprise mode questions. I'm your guy for tools. Enterprise mode, we have other people here that were no experts.
Yeah, well, no, I was saying, is all this going to filter down to Windows 7?
Yep, IE 11 is the same on Windows 7 and the same on Windows 8.1.
Shipping the same time?
I believe, yep, April, next Tuesday, April. Okay, so today, mostly just me doing demos in the browser. I'm already in the browser. This isn't PowerPoint. I'm using the F11 key, haha. Yeah, it's cunning. So I'll mainly be doing demos of all the new features. So this will be like a lightning tour of everything new we've added in F12. At the end, I'll also be talking about our scenarios we enabled for phone. So if you've ever built a website that targets mobile devices, anyone? Okay, so today, if you do that, you don't have an experience for targeting IE on the phone. Obviously we have the emulation modes in F12, but with Visual Studio 2013 Update 2 RC, soon to be just Update 2, we now have enabled you to profile and diagnose your websites that run on IE on a mobile device, be it an emulator or connected via a USB tether cable. So at any point, not just in this talk, but at any time, feel free to tweet. We watch Twitter and we'll reply to people. We're always interested in hearing feedback. That's a big thing for us. As we try to be more open, more collaborative, and update our tools more frequently, we really want to get feedback from you guys. The feedback we have from developers really does help inform our planning process, our design process, and what we want to do. So there's a bunch of ways, I'll have it on the last slide as well, for you to reach out to us. So for the first demo, I'm going to demo a new feature we just added to the debugger called Just My Code. So for those of you who are perhaps Visual Studio developers, you might be familiar with this concept. So as a web developer, you probably use libraries. You probably use third-party libraries. Libraries like libraries like jQuery, AngularJS, things like that. And of course, one of the challenges of working with those libraries, sorry, one of the benefits of working with those libraries is they really help you make applications much more quickly. They enable you as a developer to make sites that work across different versions of IE or different versions of browsers. They enable you to have patterns like MVC, stuff like that. Quick reset. All right. There we go. But one of the challenges of these libraries is it can be a pain to debug. Like if you've ever had an experience, and I'll just demo it, what you probably experience on a regular basis, you've got a site like this one, and for this demo, it's super simple. We're going to use jQuery, and I'm just going to set a breakpoint in my code. So this in the click handler is just making use of jQuery just to animate a property. It doesn't really matter what you're doing. And today, when you debug that with a tool like F12, what happens is you step in, and you end up in someone else's code. Like in this case, it's minified jQuery. That could be anything. And if you're anything like me, you want to get out of here as soon as possible. You step, perhaps you try step out. You're like, you can't understand this. There's no way you could debug this. And even if you could debug it and rationalize about it, you can't change it. You're not going to change jQuery, most likely just to fix your bug. Besides which, the problem is probably in your code. So you want to get out of here. And half the time when I'm trying to get out of somewhere, I end up accidentally completely stepping out of my own code and going back to either somewhere else or back to global and missing my bug. So one of the features we added in this release and the update is, like I said, just my code. And so the idea here with this feature enabled, which I just quickly turned off for the demo, and if we go back to that breakpoint, you can see it's still step. This time, when I press step, we're going to step just in my code. So it's all right. I'll try to take questions at the end, actually, if that works best. Okay. How does it know? So that's funny. The next topic in the demo is going to be just this. So some of you might be wondering, like, hey, how did it know? Like, do you guys just target jQuery and go, oh, you guys, this has got to be library code? So we actually do figure out what library code is in a bunch of different ways. The first one is we have a bunch of heuristics built into when we ship F12. It's on a file. It's called mycode.json. And we have this little heuristic here that says libraries, anything that matches star.min.js is a library, where star is a wildcard that can be anything. And so you can obviously edit this file, and you can do things like add star.doubleclick.net if you don't want to debug people's adverts. But that's a bit of a pain. Like, you wouldn't want to go type URLs into this file all the time. So we also have UI for this, which is the way we expect, or we'd imagine most of you will use these tools. So the first thing, in the file picker over here, you can see that there's this new column on the right-hand side with this cute little man icon with a strike through him. And so this indicates that these files are library. So you can see here, this when you have this little icon, hopefully everyone can see it, that means this file is library. And I can click here to mark code as library files without having to open that code. The other way I can do it, which is also super handy, is if I continue to my next demo, and if we're stepping, so we're stepped over jQuery, and we're going to go into this, I've stepped again, and now I stepped in some other code. So this is also some code that I don't understand. I've got someone's awesome get random number function. It's a library piece. I don't want to debug it. So I don't want to step in this file anymore. So I can mark this quite easily by going right-click, library code. And you'll note that instantly what happens is on the right-hand side, we have like the cool stack window collapsed. So library frames are rolled up into one, since you probably don't want to see frames inside a library code. You can turn that off at any point and see all the frames. And now when I step, I'll step back to my own code. So even though I changed, I jumped into a file, I said, hey, this isn't my file. I stepped again, it went back to my code. So it's a really, really useful feature to help you in your own code. And we remember those settings. So that file I had open will probably give me a warning now when I go back to Sublime, saying, hey, this has been up to date. No, let's not worry about that. And so that's where it's persisted. So you can obviously edit this file, or by the UI where we expect you to use it, update that list of library code. And similarly, if you do want to debug library code, or you want to say something matching star.min.js is in fact your code, you can always unmark the code by just doing the same context menu here, or by doing it from the file picker. And you can also do it from the cool stack window, which will take the URL associated with that cool stack frame and mark that URL as library code. But the feature doesn't just change how stepping works. Another critical thing it changes is first chance exceptions, or as we like to call them, break on all exceptions. So what break on all exceptions does is it breaks whenever there is an exception. So it's a pretty obvious name, really. And so say you've got a try-catch. That's a caught exception. And typically, we won't break on those by default. And sometimes, though, you have bugs in your code that is in one of these sections, and you want to debug it. But if you turn on break all exceptions today, you'll invariably break in someone else's code. So if I refresh the page with JMC disabled, so this is the experience without just my code, you can see I'm going to break in jQuery, step again, or continue a while. So because libraries and other people's code sometimes use exceptions either as part of their application flow or for feature detection is really common. And so by enabling this setting, it's kind of noisy. So with just my code enabled, when I refresh the page, I am not going to see those exceptions. But when I click my own code, first chance exception, which is going to try and catch, it breaks. So if the code is, if an exception originates in the library frame, is caught in a library frame, we're not going to break on it. We're just going to keep you in your own code. So again, you can filter down that noise and get your bug much faster. All right, so that's the first big feature in the debugger. The next feature is something called source maps. Who here is familiar with source maps? OK, do you use them for TypeScript, CoffeeScript, or something like that? Does anyone use TypeScript? Yay, quite a few people. So the source maps are really designed for people who are using abstractions or like languages like TypeScript or CoffeeScript, or for developers who are compiling your JavaScript. Essentially, say you take your JavaScript and you minify it. So the thing you run in your browser is somewhat different from the thing you are writing, like in your editor. So when you come to debug, that's obviously a bit of a nightmare. You're looking at the file, and it's hard sometimes to map backwards to what was in your source editor versus what it's executing. So source maps is a community it's not quite a standard. It's an open source format spec that's been worked on by a whole bunch of people outside, like Fitzgerald and John Lenz. And it basically helps that mapping. So it does text mapping. So it says, for any given position in a text document, you can map it to a position in another text document. So that's really useful for debuggers, for JavaScript. It's also used for things like if you're using CSS, like less and Sass can be compiled to it. So in F12, we've added support for this for JavaScript debugging. So in this page, I've got TypeScript. I've got a TypeScript app, and I can search for it. And you can see straight away I've got this simple.ts file. We even do cutesy stuff, like have a little icon for it. Oh. But more interesting enough, this is the code that's executing on my page. This isn't the code, sorry, that's executing on my page. This is my source code. This is what I typed TypeScript before I compiled it. And when I compiled, it generated that JavaScript file that's running now, and it also generated that map file that compares those two things. So firstly, in F12, you might notice that we have syntax classification. We have colorization for TypeScript. So it's not JavaScript types. Like you can see class and constructor are highlighted here. I can search in the TypeScript and not just in the running files. But also, when I set a breakpoint, so I go ahead and set a breakpoint in this TypeScript code. I press my button. And sure enough, I've broken in TypeScript. So now when I step, I'm going to step through TypeScript. So you can see me stepping through this super class, creating an object and stuff like that. Things that don't actually exist in JavaScript, like classes and super and stuff like that. But I'm stepping through it, which is really handy. And really nicely as well, if ever you need to compare what's actually running, because sometimes there's some things that source maps don't do. For example, if you have a variable that's renamed, like say you've taken my prettily long name string and it's been minified to A, in the console and stuff, it's still called A and things like that. So we have this simple toggle that allows you to flip backwards and forwards between your TypeScript or your compiled code, which could be CoffeeScript, it could be just normal JavaScript, to the running document, which is in like minified code, or in this case, just plain JavaScript. So you can see here, I've got the word snake highlighted. Turn that off. You can expand. And every time you step, I can go backwards and forwards between both the running version that's actually executing on the page. So when I see a console message that say X is non-defined, I can easily see where that is in my source code. And on a more complicated site, like that was a very simple demo with like 100 lines of code, I've got this awesome tic-tac-toe game that I can never beat, especially because I'm very bad at tic-tac-toe. But say I wanted to debug this page. Oh, let's turn off first chance exceptions, because we don't want to do that right now. If I go to inspect element, you'll notice there's a bunch of other places where you can come to see TypeScript or CoffeeScript or whatever your source is. So in the DOM Explorer, one of those places is if you have an event. So if you've seen this event tab, this has existed previously, but it tells you all the events that are hooked up for a given page. I click this link. Rather than taking me to the .js file, it takes me straight to your TypeScript. So I can set a breakpoint. And so this is the TypeScript event that's wired up. Press it. Again, I can hit it. And in this case, this emphasizes one of the useful things about turning off source maps, is this, in this case, is the HTML button. You know the fantastic this in JavaScript when it's the event. If you're in an event, it's the object that fired the event, the element. In TypeScript, this is almost invariably going to be the owner or the object that has that property defined. So if I turn it off, I can quickly see that this actually is underscore this, which is, in this case, the debug chapter object. The other nice thing about the feature is it fully supports having multiple files. So one of the things I mentioned briefly at the start is, of course, you can have many files that compile down to a single running file. So in this case, I've got, 6 files that compile to a single JavaScript. So if I turn off the feature, you can see you've just got one JavaScript file. Turn it back on, you've got many. So again, this dynamic nature can be helpful for you investigating more complex apps, because a lot of scenarios for TypeScript involve building large, complicated applications and not just simple demos like the last one. So the other thing that was kind of like a freebie for source maps that we added was, who here uses eval code? Occasionally, hopefully not too often. No one wants to admit it, maybe. So one of the problems with eval, there's a whole list of problems that I want to talk about, but one of the challenges is they're very hard to debug, because the inherent nature of eval means it's just called dynamic document, script block, or something like that. So it can be very hard to identify where this eval comes from, what it's about. And so if you ever use eval for something crazy like loading libraries dynamically, like you're fetching XHR and you want to evaluate text for some reason, anyway, one of the features we added was this thing that's been around for a bit of time called a source URL comment. So if I go ahead and I look at the code for this, just jumping to the no, I do not have the button. Oh, we're just in the debugger. So if I just search source maps and find the file, so you can see I've got this string to evaluate, which is just going to do nothing. But I've added this comment here, I don't know if you can quite see it, where it says source URL equals pointless.js. So this is a mechanism in which I can name files. So I can say this eval should be given a certain name, so when I break into it, bunk, you can see that it's called pointless.js here, and I can even do stuff like set breakpoints in it and things like that. And it also, lastly, it'll also appear in the file picker, still under dynamic scripts, but you can see it's called pointless.js there as well. So if you ever do use eval, you can start to de-anonymize it a bit, at least for when you're debugging. All right, let's remove that breakpoint. So that pretty much covers the features we added for source maps, which are really around helping developers who are using languages like TypeScript and CoffeeScript. And I forgot to mention, actually, we also have support for syntax colorization of not just TypeScript, which I just demoed, but both CoffeeScript, which is here, you can see demo.coffee. So this is syntax colorization for CoffeeScript. We also have it for people using script sharp, which is a C# type syntax. So it's more than just TypeScript. It's just a generic source map. So it'll work for minified JavaScript using pretty much a whole range of different compilers that support this v3 of the spec right now. So the next set of features, kind of a little more of a note. One of the things I'm sure you've noticed in F12 up to this date is that you might have had to close your IE session, might have had to close F12 while you're debugging, and you've come back to it, and what's gone missing? Almost everything. So things like breakpoints, things like the windows you had open, the watches you had open are no longer present. So that's obviously less than ideal, should we say? So what we're doing now is that we're starting to remember those things, so that when you come back to IE, when you come back to F12, you have the same experience. So for example, let's do something very brave and set for the sake of argument, just set a breakpoint. And so you see I've got a single breakpoint set here, and I'm going to close my demo, which is always good fun to do, and then reopen it. And then when I open F12, hopefully in the bottom right, you'll see the breakpoint still set. But more than just that, quick question, or? So the question was, like, when do we remember these settings? So when the browser closes, when F12 closes, when we remember these settings. And the next thing, we don't just remember breakpoints, but also along the top here, you can see the tabs I had open, the documents I had open. We also remember that. So of course, if you're debugging a site, you found the 3 or 4 pages that impact your bug. You don't want to have to go find them again and open them again. So we'll remember them. We also remember the watches, as well as other. I'm sorry?
So, like, if you're in a situation where it's remembering the compatibility
So the question was, do we remember the compatibility mode? And the answer is no, we don't remember the compatibility mode. It's on our backlog. So, and we also remember things like, obviously, there's just my code settings, as well as what files are pre-printed. So that's a pretty handy feature. So before we look at the next set of tools, a couple of shortcuts that we've added that are actually really worth remembering. Firstly, if you've ever debugged or if you're ever at a breakpoint, you're stepping through your code and you think you found your problem, so you flip back to your editor, you've made your change, you've deployed your site, and now you just want to refresh the page. You don't want to step and hit another breakpoint. Or perhaps you're in the scenario where you're currently broken at a breakpoint and you no longer want to be. You've had enough, you just want to get the F out of there. So one of the handy features we added is a shortcut Control Shift F5, which basically will just take where you are, abort it, and refresh the page. So if ever you're at a point where you're like, don't want to debug anymore, just Control Shift F5, and it'll get you out of there. Another handy thing is, I think some people, if you've used the toolbar on the left-hand side to navigate, sometimes you might have thought it's not the best way to navigate around the tools. So there's been keyboard shortcuts in F12 to help with that, and in this release, we added a couple of them, where you can use the Control and brace keys to navigate between tools. So you can go backwards and forwards between tools very quickly. And you've always been able to use things like Control 1 for the DOM Explorer, Control 2 for the console, Control 3 for the debugger. So rather than having to move your mouse to the left-hand side, you can use keyboard shortcuts to navigate around the tools. It's really useful, especially if you're a keyboard person and you're used to using keyboards. It's not like there isn't as many shortcuts as there are in something like Vim or Visual Studio, but hopefully there's enough to make you much more productive. And it's something we always have in mind when we're building F12, is that we want you guys to be productive as possible, and adding things like this can save you a bit of time. So next set of features are all going to be in the console. So the console received a bunch of updates in this one. Probably the biggest and most needed one, if I just clear my page, was something called console.log, logging an object. So take, for example, console.log. Normally, you'd have this in your code, in your page. For the sake of argument, I'm just putting it in the console. And now when I log, you get a fully inspectable object. So we're not just showing you a string or the toString specifically of that object. You have a fully inspectable object that you can drill down and spend the rest of your life looking into, especially if it's the window object. And it's recursive anyway, so of course you can. Anyway, the other things, it isn't just logging simple objects, but we also support logging multiple objects. So you can do things like document.title, window, and of course this could be as many number of you want, and we log them all as an array. So you can log multiple objects to the console, and you can inspect them separately, just as, say you're making multiple calls to console.log. The other thing that can be really handy is if you ever use console.log to log a string that's taken a variable, like you've done something like log a number, like said x is 10 at that point, and you've always had to do like end quote plus variable name, then maybe plus again, open quote next part of my string. So one thing we've improved a bit in this release is what we call, I guess, the printf or argument substitution. So if I just copy some code rather than, let's minimize this. Oh, here we go, it updated. That's Sublime's Watcher. So if I just go to my favorite editor, okay, Notepad, just copy some code. And so in this example, what I've got is I've got that's really irritating. I've got a message that I'm logging, and it's taking the percent. You can see that first percent, an S, which means it's a string, and then I'm passing in two arguments, document.title and new date. And then I have a message. And so when I run this, what's going to happen is we're going to substitute those arguments in place and show the formatted string. But more than just that, what we do is we also allow you to inspect the objects. So you can inspect the parameters, the arguments that were passed in to the console.log. So here I've got the unformatted string, I've got the string from the document.title, and I've got my date function. There's also formatting. So we support basically strings and numbers. So in this case, say I wanted to take the new date in its number form, the number of seconds. Then I just do D for decimal, and you can see now it's formatted that as a number. But I still have the object to inspect, which is pretty handy. The other probably biggest feature for the console logging was we added the capability to log messages before the page is displayed. So if you've ever been to a website and it's been broken, like your site's been broken, you press F12 to see what's wrong, and there's nothing staring at you, and you're like, why is it broken? Thank you. And you press F5, and maybe you get that same error, or maybe your repro went away. With the updates, there's now a capability to, in Internet Options, under Advanced, everyone's favorite menu, there's always record developer console messages. And so what this will do is, regardless of what site you're on, before F12 is loaded, we will be logging those messages, those strings, and we'll display on the console. So I've got this broken site that I'm just going to open. So if I open it, and I look in the console, what you can see is I've got the warnings about my unclosed tags, and I've also got some messages from the page. So if I look to the code in the page, you can see I've got console.log, and you can see if I open up the console just using Control tilde, they've been, or tick, they've been logged to the console as strings. So even like console.log and stuff like that will get logged. These ones are strings, they're not objects because we're just keeping around strings. And that will be there regardless of the site you look at. So that covers some of the logging stuff in the console. And the idea here is we try to improve the console's logging capabilities so you have a much richer experience for instrumenting your code, because that's really helpful in debugging. And I'm pretty sure everyone here uses console.log. So the next set of things we've improved a bit is a way in which you can target different iframes. Like this application, this demo, has a lot of different iframes. So if I was in one of them and just did document.title, you can see this is in the developer tools one. If I go to the console one, we'll get a different value, and you can see this little message telling me. So it allows you to switch very quickly between different iframes. So if you have a site that is composed of iframes and you want to have your console execute commands or evaluate objects against that iframe and not your root iframe, easy way to switch it. And you should be familiar with this. The other kind of nice thing we added was a little shortcut for what we like to call $underbar or dollar underscore. So who's here familiar with some of the $dollar shortcuts we've got? Not many, a few people. So there's a bunch of shortcuts we have that's worth mentioning. Things like, for example, if you have something selected in the DOM Explorer, it appears as $0. Oops, if I didn't type in the class section. Yes, that's because it hasn't selected. But we also added things like this $, which is the last evaluated expression. So if I do document, and then I do $, it's pointing back to that. So this is really useful in scenarios where you've executed some code and you want to then look at a property or execute a function of that return result. So an example, if I go back to my notepad, why isn't it like this? Is like, say I'm going to take the, I'm going to get the body element. And then in the case I want to look, it's a node list of 1. So I'm like, well, I want to get to the first element. I can obviously press up and then do parentheses, brace indices. But instead I'm going to do it this way. And if I do it this way, the nice thing I get is IntelliSense. Because obviously when I just press up, I don't get IntelliSense on the object properties, but now I will. So I can see inner HTML. So you can use this as a way to inspect the last object that was logged to the console and get IntelliSense and things like that. The last feature we added that really helps, like sort of like using the console as a REPL, like executing code, is the autocomplete. So as I type, autocomplete will now include things in the locals. So if I'm at a breakpoint and I have some local variables on the stack, they'll also appear. So hopefully this will make things a bit easier when you're working with things like iframes. So the next set of improvements I'm going to quickly demo were in the memory tool. So let's go over to that. Firstly, has anyone here investigated a memory leak? Those without your hands up are very fortunate people indeed. But for those of you who have, you'll notice one of the biggest challenges when you come to investigate memory leaks is the sheer amount of data that's presented to you. Obviously, memory leaks tend to be complicated because your application probably has tens of thousands of objects in it, and it's very hard to find those few objects that can be responsible for holding onto memory that you want to be freed, no longer present in your application. So we've added a new feature in the memory tool where you can do essentially a freeway snapshot. So I've taken a baseline snapshot. I'm going to run my scenario, take another snapshot, and then I'm going to run my scenario one more time. And this workflow is trying to help me figure out what's left over. So I've got my baseline, I start my scenario, and that will do any like static initialization, like say this scenario requires the creation of objects and stuff like that, it'll do all that. So in this case, that refresh button I was pressing is just actually just setting my score to 0, it's reloading the images, it's not doing anything particularly exciting, but you can imagine if you're writing a mail application, you press the new mail button, that probably loads some libraries, does some things, you close it, and that's your new baseline, and then you can run the scenario again, a third time, which I think I did. This is where I found out if I did it or not. And so obviously, between the baseline and this scenario, you can, no, I didn't. My bad. Let's do that try again. This is doo-doo-doo. And so what this will let me do is it will show me what the objects are that are left over, the ones that are essentially hanging over. So in this case, unfortunately, I didn't do, let me refresh the scenario again. Let's just do that, F5, take a snapshot, do. Take another one. And so again, you can already see in the top right, this is a feature that's currently there. We have these little information warnings that tell you there might be something wrong. In this case, it's telling me about detached DOM nodes, and I'll get to look at those in just 1 second. Great. So the thing you might have noticed on that summary page is this is a non-symmetric growth. Like here, I'm creating more objects than I'm freeing in between 2 points in time. So that's a pretty good indicator that something's leaking. And here, this is what we've just added to the update, is this scope filter. And so what this is going to do is going to reduce that set of objects down to just the ones that have been left over. So here you've gone from like the 2,500 I have in my application down to just 156 for me to look at. Because ultimately, as a developer, you have to decide if these things are leaks or if they're just part of your application. So to zoom in a bit on that. And so you will see that like in this list that I've got now, which is much smaller, firstly, you'll note that there's these warnings at the top telling me I have some detached DOM nodes. So these are scenarios where you've created an element, like a div, an image, whatever it is. It's referenced from JavaScript, but it's not referenced to the DOM. You know, it's not a child of document.body or anything like that, or head or whatever. So it's never going to appear on the screen. So the tools don't know this is a leak. You can be doing this for good reasons. You know, it's impossible for a tool to know. But it says like, hey, maybe you should look at these. And then, of course, when I expand into them, you can instantly see how much memory they're holding on to. And this is the same great data we have today, where we're telling you things like the tag name, the class name, the style, the ID, and source. And so very quickly, you should be able to get back to where the problem is and essentially free that memory. And the way you do that, this hasn't changed, is looking at the object references graph. So the object references graph, I'll very quickly mention, is a way in which you can see all the things that hold on to objects. JavaScript is garbage collected, so we free objects by removing references, snipping references to it, and then the garbage collector will come along and take the memory. So of course, any object can be referenced by any number of components, and so we have this other view at the bottom that's telling me that something called rootl, so this is an identifier in my code, so if I go to the debugger and search for it, I'll be able to find it. But this isn't, in this case, this isn't actually the interesting part of my code. And of course, I can go through it. What is interesting, though, if I go back to the memory tool, is that you can see there's a slightly subtle different color, which I'm just going to call out because it's quite easy to miss. This light gray italic font means that it hasn't changed. So we're looking at a snapshot view, and so it's important to distinguish between things that have been the same for however long, and they're just referenced here because they're part of that route, the path back to global, versus things that have changed. And so you can see this is the path for this object keeping alive off the window object. So normally I could go back to my application, I would search for where this moving L list is and see why it's coming, why it's staying around, why it's keeping hold of these. And this particular application, which I'm not going to change, it was just because I didn't empty the array. Like I have an array of these objects, I'm keeping them around, I forget to flush them. Pretty obvious. Unfortunately, I'm sure as some of you will find out when you come to look at memory leaks, they take a lot more effort than that to figure out. But our tools really try to get you there as quickly as possible and reduce that huge amount of data that you have to look at. And that's really the challenging part when looking at memory leaks. So things like freeway snapshot, as well as the improved UI, we've got grid lines, these nice little filter objects that show built-ins. So if you're curious, built-in objects, as well as IDs, which aren't particularly useful. So the next set of stuff, actually, I'm going to demo in the phone IE talk. So we've also made some improvements to the visual profiler, which I'll allude to later. So then, you'll appreciate it when you come to do memory leaks, for sure. It's a huge change to be able to reduce that set of data you're looking at, and that's what a lot of these tools try to do, is try to get you to your problem as fast as possible, either in just my code by keeping your code, or in the memory tool by trying to reduce that noise. So the next set of features I'm going to talk to are in the DOM Explorer. So I'm sure you all know the DOM Explorer. This is the tool you use to inspect your HTML, inspect the CSS, and then inspect how it's rendered on the page, and to trace styles. So many of you, no doubt, use this tool to tweak values. Like whoever goes into a tool like this and changes things like margins, properties, paddings, pretty much everyone, I'd imagine, even if you're not putting your hand up. It's like the primary use case. So obviously you do stuff like, oh, let's make this 2EM for fun. Well, that's great. That's just what I want it to look like. But you'll notice right away that we've got this little change bar, we like to call it. This little notice here that says this property has changed. It's different from the value that you started with. Because one of the challenges that certainly for me and many others is that when you're tweaking a site, it's easy to forget what you changed. And especially as you go around, you change different elements, and it's all of a sudden, it's hard to keep track of what has changed. So very similar feature, like if you've seen obviously things like Word and track changes and stuff like that, similar sort of concept. You want to keep track of those changes. And so that's what this tool allows you to do. So if I say I no longer want a text decoration, so I delete that. I want to add a new property, so let's go ahead and add a color. Okay, let's make it hot pink, because that just looks awesome. And as you can see, we've got different colors to indicate when things have been deleted, when they've been added. So we keep things in deleted that have been grayed out, because at the end of the day, it's important for you to know that something was deleted. And the nice thing about this is you can also go ahead and revert the change. So if, for example, I decided hey, actually, I wanted text decoration. I didn't mean to delete that. You can just do right-click, revert. And you can do that on properties and rules. So I can revert all my changes for the rule, and bang, it goes to that right how it was at the start. And now I quickly have to do those changes again for the next node. And this stays around. As I move around, as I select different nodes, if I come back to that, it's still going to be there. It's per CSS rule. It's not about the element. It's about the CSS. It's all about tracking changes to CSS. And the nice thing is we don't just show it here. We also have it in this, what we call the Changes tab. So this tab is going to list all those CSS changes you made to your site while you had the F12 tools open. It's going to list them out in a diff view. It might not come out great on the projector, but there's a light red color for when items are deleted, a green color from when items have been added, and this little black color when property values have changed. And so this allows you to use a checklist, because perhaps you've got your CSS editor somewhere else, you're in a different machine, you're remoted into a VM or whatever. You still need to make your changes from those changes you made in the tool and take them back to your editor. And this is exactly what this feature is for. It also has a handy copy feature. So I can go back to my favorite editor in non-minimized mode and paste it. And so this pastes the final value. So the idea is you could just override the CSS file. So we're not handling editing, because F12 is all about helping you debug, diagnose, and inspect. We don't really mind what editor suite you use. We just want to help you get the data, the changes you've made in F12 out and back to wherever you want to put them. And you can also revert changes from here, just by doing revert. Bunk. So the next feature in the DOM Explorer that we've added to try to make life a bit easier is if anyone's ever used a hover style, like a hover pseudostate. Okay, probably everyone has at some point for table rows and stuff like that. So in this case, I've got a very simple hover style that's just changing the height, animating the height of something. But that's really difficult to debug today in F12, because there isn't a way in which you can hover over something and use the tools, unless magically you have two mice, which is something I believe Windows does support. Anyway, multi-input touch, multi-input. Anyway, here, what we can do is there's this new button here on the top right of the DOM Explorer called the pseudostates panel. And what that allows you to do is to force a state. So in this case, I'm just going to force hover, which obviously applies to the And so this applies the hover style. And right away, you can see I've got the hover style applied, and I can go ahead and change that also to be, tell you what, let's add a new property. Oops. Let's go add property. We'll go color hot pink again. And now when I zoom out, it's changed. And again, this takes part in those track changes stuff. So if I go to the changes tab, you can see the hover rule has been changed. So when I copy that, it'll also have that pseudostate in the selector, which is obviously very important. And the other one we support is, we haven't got them all yet, but we do also support visited. So for people who like to change the style of things between visited and link, the two states for hrefs, A tags, sorry, anchor tags, you can easily do that. The last little change we made in the DOM Explorer that's worth mentioning is we combined the computed and trace style views. So we used to have two tabs that essentially perform very similar operations. And so now we just have one tab called computed. And what that does, as you might have already guessed, is it shows both the computed value of something. So if I look for font, and by the way, there's also a very handy thing, use the search box to filter properties, because obviously your CSS probably has lots and lots of properties. So here I can filter it, and I can see that the computed style for something is 75.93, but the relative, it was set as EM, the relative measurement, set by reveal.min, which is the library I'm using for my demo. But if I go ahead and change that, of course, it's going to update the computed. But the nice thing is that we've added editing and back to source in this view. So you don't have to switch the other view to do that, which wasn't possible in the last, which is also a really handy change. So the next, probably last bit of my demo is going to be about the phone. So for the phone, we've added a bunch of support for debugging IE on Windows Phone 8.1. So I think you've all seen the announcements where IE 11 is now on Windows Phone 8.1. And so one of the great things we've been able to do in collaboration with the phone team is fully support our stack of tools that are in Visual Studio against that phone, against IE. You can do this both, as I'm about to demo, by attaching to websites, but also if you're using ASP.NET. Is anyone using ASP.NET here? Some people, maybe? Quite a few people. What a surprise. So if you're familiar with that targets drop-down, one of those targets will be phone, and you can have either the emulator, or as I briefly mentioned, USB cable, and you can tether your device if you have a Windows Phone 8.1 device. So let's switch over to Visual Studio to show you the actual demo. And the nice thing about this is that, let's close down some of these things, is that our tools that we build, like the tools I just demoed, like all the changes to the DOM Explorer and all those changes to the console, are also in Visual Studio. So Visual Studio is, let me just close this. We share those same tools in both places. So you get all those features I just demoed for the DOM Explorer, the console, and the memory tool in Visual Studio. So what I'm going to go ahead, firstly, if you ever want to debug IE using Visual Studio 2013 Update 2, you have to look in other debug targets. And this is the place in VS where we put those options that aren't directly project related. Like say you want to launch a Windows Store app that you don't have source code for. So we've added a new one called Debug Windows Phone Internet Explorer, which, as you can imagine, is going to do what it says on the tin. And so you get a dialog, which I briefly glimpsed over. And let me just show you that again, actually, sorry. And now I pay the price for executing a stop command halfway through. So in this dialog, you get a couple of options. Firstly, you can choose the target. So there's a bunch of different emulators for the phone that are shipped with the SDK that are part of Visual Studio. Different form factors, different memory in the case of the 512 meg RAM. And also there's the tethered device option. And then lastly, you choose a URL to launch at. The idea is that you can debug any site. Just so long as you can browse to it, you have access from the network to it, you can debug it. So it could be localhost. In fact, I could probably just show localhost if I still have it in my list. And localhost, obviously, in this case, means my developer machine, not the phone, because that would be really annoying. And then when it's attached, what we'll be able to see firstly is the script documents, the debugger code. So this is where you can set breakpoints, so you can see the code that's running. But you can also see the DOM Explorer and the other tool. So if I just open those, for some reason they didn't appear. And if I go to, if ever you're looking for where the DOM Explorer and the console is in Visual Studio, they're in the debug menu. You can see the JavaScript console. You can also see the DOM Explorer here. And so this time, I can use select element. I can select sync on my page using the emulator, and bang, it selects in the tools. And just like everything else, I can go ahead, I can tweak properties, I can change things. I can use the same set of tools that you've used for Windows Store applications, or if you've used them for IE. And indeed, those same tools are in F12. So here, of course, you can see the changes. And in the console, same experience. You can do documents, you can inspect the window object, you can log. And this works remotely against a tethered device as well as against the emulator. The other thing that I mentioned I'll show is the profiling. So most of the time, to be honest, you're probably going to do your phone debugging on your desktop, maybe using emulation modes in F12, but mostly you're going to be more productive because deploying to a phone is always going to take a bit of time. But for some scenarios, you really have to use a device. That's typically for profiling. Like as you can imagine, the browser platform, the rendering engine, the HTML and CSS are hugely converged. There are some small differences, things like viewports and text scaling and stuff like that. But by and large, you're not going to have functional issues that are different on your desktop than your phone, by and large. But one thing that is most definitely different is performance. So you can have a site that looks fantastic on your desktop, runs really smoothly, it's fast and fluid. But on a phone, it's really janky. Drops frames, really slow to catch up. So we support all the performance tools that we have against phone IE. So again, you select the target. In this case, I'm going to pick on msn.com. And you can see here, we've got a selection of different tools. So you can see the memory tool that I demoed earlier. So if you want to look at memory tool leak, you can look at that. And memory, of course, on a phone is much more important because phones are much less available memory. And on many operating systems on the phone will more aggressively kill websites or tombstone apps that take up memory. So in this case, we're going to look at UI responsiveness I'm going to use CPU usage. And a nice thing that was just added an update to Visual Studio is that you can have these multiple tools. Like, I don't know if you saw Kevin's keynote demo where he showed for XAML the same sort of scenario, where you've got the XAML profiler and the CPU profiler. In this case, we've got the HTML UI responsiveness tool and the CPU tool. So we're just going to go ahead and launch that. And that will go ahead and launch Internet Explorer. And now we have to just wait for a while for the network. We're going to do a bit of scrolling. Or click a link accidentally. Okay, a bit of scrolling. And you can see this live graph that's updating with the real CPU usage. And we stop collecting. And so what this is going to do is going to take the trace report we took from the phone, bring it over to Visual Studio. It's going to process it and build those graphs. So I think everyone's probably familiar. Has anyone used these tools before in F12 or in Visual Studio? OK, a few people, so I'll give a quick introduction to them. Along the top, you can see here is a timeline that you can delineate. They have the when DOM content loaded events fire, and you can also alter this timeline by writing performance.mark. So performance.mark is an API you can use. It's in all the modern browsers. And if you use it to instrument your code, so you typically use it to instrument your code as it's running on a customer's website, and then you upload that data and have some real-time telemetry about it. But if you use it in a profiling session, it'll also appear along the top here. So you can instrument your code, because pretty soon it's going to be very hard to know what happened at 10 seconds versus 15 seconds. So if you instrument your code, you can see that. So the next thing below is this graph that divides up CPU usage across the different subsystems, particularly around loading, which is a network often, and parsing, scripting, that's JavaScript execution, styling, CSS, and rendering, which of course is drawing the screen. So you can see that the tools work, and you can see right here where we drop frames, like we've almost gone to 0, which is probably a problem. You can also see the CPU usage, so you can see how much CPU you're using. For the sake of the demo, I was using the emulator because I didn't want to connect up all this fancy stuff. But obviously, in real life, you probably want to use an actual device for profiling, especially since your device probably isn't running a Core i7, unless your pants are quite literally on fire. So the nice thing here is that we have the data, and we also have those two tools. So you can also see the CPU usage, which of course is probably going to be execution. Since what you're going to inevitably do is you have to try to figure out where the problem is. Is the problem going to be in your HTML and CSS and the rendering there, or is it just in flat out how long JavaScript execution time takes? And so we added a bunch of features to kind of help with that. One of the features we added in this update is if I select a time range which has an event, the first thing you can do is the narrow context menu to filter to a particular event. So one of the problems, again, I mentioned is that there's obviously a lot of data in these sort of profiles, and you want to narrow down to the thing that you're focusing on. An easy way to do that, rather than fiddling with this little timeline up here, which looks cool, to be honest, is that you can just right-click, filter to event, which will take all the things that happen during that time. You can also do things and filter out network traffic. So sometimes network traffic is obviously very important, especially on websites. It can be a huge contributor to the performance customers see. Sometimes, if you're just looking at a client, if you're trying to focus on JavaScript or HTML and CSS, it can represent a bit of noise. So you might want to filter that out. We also now filter out background activity. So as I'm sure you're aware, things like IE and all modern browsers do a ton of things off the UI thread and different things that you might not care about. Since typically you're not responsible for that, you're not responsible for deciding which things go where. Obviously, you have an indirect influence on it, but there's not always much you can do. So that's the new features we added in the UI tool, which are really around helping you filter and get back to the data as soon as possible. So back to the talk. So I think, long pause, that actually concludes the demos I had. So as you've seen, I think there's a whole lot of features we added to F12. Obviously, things like just my code, source maps, improvements to the memory tool around that three-way snapshot to try to get you back to find those objects that are leaking in some scenarios as quickly as possible. All those features I demoed are available in both Windows 7 and Windows 8.1 with the updates. So the announced update on next Tuesday, the 8th, I believe. In addition to the features in F12, in addition to the features in F12, we also have obviously shown you the stuff that's added to Visual Studio Update. So for those of you who are debugging phone apps, you now have a whole experience in Visual Studio. But lastly, I think the most interesting thing for someone like myself who's worked on the team for a while is just that we've added all these features in a relatively short time for us. We've been able since November and October, I believe, with the release dates for 11 on 7 and 8.1, sorry. And now what? It's April. We've managed to make some big strides, got a lot of features in there, and hopefully we're going to start keeping that momentum. moving more features, getting things to you faster. Because at the end of the day, we want you to make awesome sites that run beautifully in IE. And improving our developer tools is a great way to do that. So at any time, you can always reach me on Twitter or an email. There is no longer that experts booth area since they took that down. So I'll take some questions here, but then afterwards, I'll just be hanging around, firstly down here and then outside. So if anyone has any questions, oh, now the mic works. Haha. Feel free to go up to the front.
Just
To the two mics.
going. Just a quick question. Just a quick question.
Yep, shoot.
Is, can you devisit actually visited links?
Pardon, sorry?
You devisit actually visited links in terms of style.
It's just styling. So we don't go ahead.
You said you could go to visited or your visited link, can you have an actually visited link?
Yeah, so the question was, can we set for a link back to the link state, which is the not visited state? And so the answer is, if you toggle it on and off, it'll actually do that. Like, it's essentially an exclusive thing when you toggle it. So it flips between the link and... so let me double check, because I think the first state is actually the default state, which is what the browser has it at, like if you visit it or not. And then when you toggle it, we change it. But I have to double check that, to be honest, because we debate that a lot. Okay, next question? Yeah, sure. In fact, I'll just take questions down here. It's probably going to be easier for everybody.